Welcome everyone to our, I guess, our first unit exam review office hours. I guess it's hard to believe we'll have 8 of these in addition to any other office hours that we have throughout the year with skill builders and whatnot. But we've got a fairly decent sized group and that are attending live. So hopefully they've got some good questions that they can throw out here in a little bit. And of course, I've got some things that I, of course, want to share with you as well. So we're going to go ahead and get going with this because I want to spend just a few seconds talking about the exam format. Of course, you can always look at your course description. That would be the document that you got on the very first day of class. If you remember, I gave you a bunch of questions over that document that you were to fill out and turn in with your graphing, calculator, and you guys did a good job with that. But the exam format probably wasn't something that was really on your mind the first day of school, and it shouldn't be. But now that we're just, about 14, 16 hours away from taking your first AP calculus exam, it probably is. So what is going to happen when you guys are in the room? You will all get the very first part of the exam, part 1. It will only consist of 5 multiple choice questions and 1 free response. You will be instructed to have your calculator out, and all is like pretty much kind of like it is when you take a quiz for the most part. Now, what will happen is that you will work on this part, as quickly, but of course, as carefully as you can. Once that, we'll talk about timing in a second. Once that part is finished, you will physically get up out of your chair and you will bring that part to me. I will match it up with its corresponding second part. I will staple it for you. And then you would actually take both parts back to your desk. But at this point, once you get up out of your chair and come to me, you've relinquished the calculator for the rest of the test. So even if you wanted to go back and do some things with part 1, you wouldn't have the calculator. Now, in all fairness, I will tell you right now on the exam that you are going to be taking, there is very little calculator interface at all. And I've had a lot of students tell me that they never even turned their calculator on for unit 1. And the reason, well, I guess there's a lot of reasons, but one of the reasons is probably that you're still learning the calculator, getting comfortable with it. And I didn't want to throw that extra kind of stress your way because limits are hard enough, right? But you'll find out that the amount of calculator active interface typically will increase with each unit exam that we take. But I wanted to go ahead and give you the option in case you wanted to have that calculator out. Both parts of the exam typically take about the same amount of time. I know that seems kind of unusual because, wow, part 2's got 5 more multiple choice questions on it. But I find that typically that's the case whenever there's a lot of calculator use. It may not be the case so much on this first unit exam. So if I were to draw upon past experience, on average, this part takes around 30 minutes, and that's actually probably a little over. I know that some of you will probably finish it in 15, but I would say 30 would be the long range. Probably more likely the larger groups coming up will be more at the 22, 23-minute mark. And then if that's the case, then this one would be about 35 minutes. But remember that however quickly you finish the first part is how much time you'll have on the second part. And so I count on you'll have about 65 total minutes. That's what the exams are written for. If we get through our Q&A session a little quicker, and if I feel like, hey, we could just start the test earlier, we may do that. But you have to keep in mind that pretty much whatever I do for period 3, I will record that time so that all 3 classes are going to get the same treatment. So hopefully that makes sense to you guys. Period 5, I know that with our split lunch, there could be a little bit of a change in terms of I might withhold one of the last pages of part 2 until after lunch so that a lot of the test is going to stay secure. But I've got multiple versions of the exam, so we may be okay. I've done split lunch before. It's been a long time. But that's how the exam is going to roll. And once you see the exam, the scoring page is at the back end of it. you probably won't pay a whole lot of attention to that. There's a multiple choice page where you enter all of your multiple choice answers so that I can grade it very quickly. We don't bubble in anything. Um, you can write as much in the exam multiple choice sections as you want. I'll remind you to fill out that multiple choice part because that's how you get the curve. You don't want to leave my classroom without filling that out. Trust me, I will make sure that nobody leaves my classroom without filling that out. So that's what the exam is going to look like. If you want a little bit more detail, of course, you can probably read through the course description. They'll even kind of tell you a little bit more about, how it's scored, what the curve, and I hate using the word curve, but that's what it is, how that works. But it's just, it's a scoring formula very similar to what the College Board uses for their tests. I don't want to like make anybody feel, I don't know, overconfident. I will say that average grades, average class performances on a unit exam are always better than our hardest to middle quizzes. The quizzes don't have a lot of forgiveness. You guys know that. You miss a multiple choice, there's an 8 out of 10. It's not fun. That's why we can drop quizzes. But at the same time, if you really prepare yourself, you can do really, really nicely in this category. The unit exam category isn't really one of the hardest categories to score your points in. I think the quiz category, as many of you are finding out, is certainly a little bit more challenging. So please let me know either via voice or a chat message if you have any specific questions over a format of the exam, and I can always circle back to them and get those addressed if that's okay with you guys. Second thing I want to talk about before I actually get into the exam type of materials is I've just opened something up in AP Classroom. I don't know if you guys have like notifications set up. It's likely, no, I don't have virus threats. It's likely that most of you don't, which is totally okay. But I'm going to show you a student view of what AP Classroom looks like. Hopefully my daughter's okay with this. I didn't ask for permission, but there's no confidential information in here. It's nothing that you would see. You wouldn't see any like performance or scores or anything like that. But when you click on that Unit 1 course resource, you guys probably know by now that you can scroll through and you can watch any of these videos. They're all very short. There's about 3 or 4, 2 to 3 for each topic. Yes, I know you're not going to look at all those tonight. That would be silly. But my challenge to you would be if there's one or more of these topics that you're like, that's the hardest one for me. That's the one that I'm struggling with the most. It wouldn't do you a lot of harm to maybe take a look at one or more of those videos. You could probably just sit down in a seat, chair, bed, whatever, and watch and probably earn a point or two more than what you may have earned had you not watched the video. Just saying, it's something that I know that some students in the past had highly recommended. The other thing is I have opened up the progress checks for Unit 1. Those would be these 3 parts of multiple choice that you could. Now notice this one starts with multiple choice question part A, and you can only work through part A. I think there are 16 questions. Once you answer all 16, you will get the feedback that'll tell you how many you got right, how many was missed, etc. And they'll even break down what the actual solution looks like and show you the step-by-step work. The questions are hard, I'm not going to lie. Multiple choice questions sometimes tend to be challenging. If you can get 50% of those multiple choice questions correct, you're doing very, very good. Because by the time they kind of factor into the curve for the exam, I would say that it's going to probably bode well for you. Are the multiple choice questions on my test always as hard as the ones on the progress checks? No. I have a few that are considered depth of knowledge 3, which means they're a little bit higher. So of the 15 questions, 2 to 3 might be that. Most of them are going to be in the middle, depth of knowledge 2. A lot of our quiz questions fall into that range. So of the 15, I would consider 12 or so to be in that range. And then maybe about 2 or 3 questions, maybe sometimes 4 questions could be even easier still. Depth of knowledge 1, which we don't see quite as often on the quizzes. Every now and then, 1 or 2 might show up. But this is a wonderful thing to do. It is a pretty heavy time investment. I would say you could focus on this maybe once you've looked at the review packet as much as you feel like you can look at it, and then you can start to look at any of these. Normally, I will have these released much more in advance to the test. I wanted to take this chance in a review to be able to show you, first of all, how to work it. I have a lot of kids that never look at the progress checks, take my exams, and do very well. But what's typically going to happen is that you might find yourself in that situation where the multiple choice is always the weak spot. You're doing great on free response. Maybe some of you are kind of feeling that vibe so far on the quizzes, and you always will come, those kids will come to me and say, well, what do I do to get better on multiple choice? And I will always direct you to the progress checks. Okay. If it's flipped around, if it's the free response that's a little bit worse, the multiple choice is going well, there are other things that I can open up for you in the AP classroom to help you with that. And I typically, again, won't do that the night before the test. But I just wanted to show you various resources that you guys can still look at if you really want to get yourself really confident off to a good start tomorrow. All right, so let's go ahead and dive into this thing. Hopefully this looks familiar. This is what the first page of your review guide looks like. I'm going to scroll down, and I'm actually going to take a look at the very last part, problem 15, because I want to make sure you understand what the expectation is for some language. It's likely that most of you here watching probably have a fairly good understanding of the 3 criteria to be continuous at a point. But there's one thing is to know what they look like on your page, but there's another thing to be able to sort of write them out the way that the College Board and me, Mr. Meunier, wants you to write them out. So let's read this and I'll kind of show you what the expectation is. It says, use the definition of a continuous function at a number to answer the following. Be sure to use reasons based on the definition of continuity at a point that we discussed in class. So part A, it says, f is not continuous at x equals -7 because. So we scroll up and we are using this graph. Let's make sure, are we not continuous at -7? Nope, we're not. So what would we say? Well, let me tell you what you can't say, because there's a hole. That will receive 0 credit. I'm impressed that you know that's a hole, but let's be honest. We could probably teach that to some students far younger than juniors in high school to determine if that's a hole. So I want a little bit more reasoning. And so you have to look at this and see, oh, it's because, well, there's no y value, right? When the x is equal to 7 or -7. Now, the thing is, y value is very vague. I want very precise language. What's the name of this function, everybody? His name is f, right? If we have a function called f, it's really important that you call him f. If this function was called g, it's really, really important that you call him G. You don't want to be called by the wrong name, right? Sometimes I do that in class because I call you by your older brother or sister's name, and I feel awful about it. I do. But you know, we want to make sure that this is correct, and here's why. On a free response question, if you refer to a function, let's say the function was called G, and you called it F, you might be okay. Sometimes we'll just say, you know what, that kid misspelled G as F. It's all right. But if that problem also had some function in the stem of the problem called F, and say another function represented by a graph called G, if you call GF or vice versa, you're not going to score the points because you're referring to the wrong graph. So I just want to kind of put that out there on the radar because it happens tomorrow. It will happen. Call your functions by the right name. And if you do that, you'll avoid a little ticky-tack point deduction. All right. So why doesn't this function be continuous at -7? we will say because f of -7 is not defined, right? If you said does not exist, I would kind of cringe my teeth a little bit and think, but I would not count it wrong. Remember, we use not defined for a numerical value that doesn't exist, doesn't have an answer. We use does not exist if a limit doesn't have an answer. And consequently, later on, when a derivative doesn't have an answer. Okay. Now, I laugh at this because students are like, I don't like to write this. And I say, well, what would you rather write? And they say, well, because there's no y value when the x value is -7. And I'm like, really? You'd rather say that? You guys, that's why this notation is used. It's because it saves you time. Okay, it causes you to not have to write as much. Would I score that phrase as long as you use the name of the function f? There is no f value on the graph when x is -7. Yeah, I would probably count that, but you're working a lot harder than you have to. All right, f is not continuous at 2. Let's take a look again at the graph. I would agree. The function is not continuous at 2, but it's not because f of 2 doesn't exist, because right there he is. It would be because of something different, right? And that something different would be because the limit that you have here, which is some answer, it looks like it's 3, is not equal to that f of 2. And so this is where we need to see that in notation. So you would say the limit as x approaches 2, and it would be from both sides, of the function f of x is not equal to f of 2. It wouldn't matter which one you put on which side. That would work. I would like to give you some wrong answers here. If a student said this, I am going to have a problem with that. And I get this a lot. Because the limit of f of 2 as x approaches 2 doesn't really make a lot of sense, because it's the limit of a point. And that's really something that we never discuss. So you have to use the right notation. And like I said, I know you can sit back and think, man, I know these rules really well. Knowing the rules just by looking at them from paper and being able to kind of write them the way that they need to be written on problem number 6, this is going to be the first free response question, can be a little bit different. All right, so you want to practice that. Okay, and then for part C, f of is not continuous at 4 because of, and I want to make sure that on some of the documents, depending on which ones that you guys got, there's a little bit of a stray mark here. This thing here is not a dot that's part of the graph, nor is this. This dot here should have been at the end of that, and it just kind of jumped on me, and it just didn't kind of work out really well. And I'm just double checking. That is what this sketch should look like, you guys. Some of you have a cleaner copy. It just depends on the version you got when I passed it out. So at 4, what's going on at 4? 1, 2, 3, 4. Well, yep, there's definitely a discontinuity, but the reason looks like it's more because of the limit. Wouldn't you agree? This is definitely a limit that does not exist. So we just have to make sure that we state that the right way. And so use the notation, be specific. Don't say as x approaches c, which is what the general version of this continuity definition says. You have to say x approaches 4. It is both sides. The function's called f of x. And then I don't care if you want to abbreviate does not exist. I'm totally okay with that. But that would score you points right there. You know, if you're able to reason through these 3 things, you've got the potential to score 5 very easy points on the first free response question. But again, you have to write this out and you know, be very, very precise with the language. All right. So hopefully that makes sense and works out. I want to just address really quickly problem like number 9 here, because I had some question about this through Schoology. What's the limit as x approaches 0 from the left of f of x? Well, if you go to 0 from the left side, it seems like we're going down, 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 down to negative infinity, right? But then if you look at my key, you see a does not exist after that. Well, in all honesty, this is the best answer, to say negative infinity, therefore doesn't exist. Let's say if this is like some kind of a free response question, that's what I would like. I do not have a free response question like this on this exam tomorrow, okay? But I might have a multiple choice question like this. And in the multiple choice question, this would not be a choice, the D and E. So you would have to be able to extract the negative infinity. But by and large, anytime a limit has an answer of infinity or negative infinity, you are allowed to say does not exist. It's best to say both. And that really applies if it's a one-sided limit, or in the case of 8 here, a double-sided limit, which in this case, we would only be able to say does not exist because we're kind of going in both directions. Okay, so I hope we're a little bit more clear with that. All right. So what was the next thing? I forgot. What was the next thing I wanted to talk through just really quickly with you guys before I open up some of the questions that we had? Yeah, I'll go ahead and hit it. 25. This kind of goes hand in hand with what we were going to be, one of the things that I wanted to talk about regarding the quiz that you guys recently took. I will say that on that page, the page that I'm looking at of your review guide, I put some pretty tough limits on here, guys. 16 all the way down to 25. I mean, obviously, I don't have this many limit questions on the test since there are only 15 multiple choice and 2 multiple part FRQs. But I probably will take the chance to waste one of the, not waste, but use one of those problem slots for a problem like number 25. And so I do not require that you guys show all of the work for this, but the idea is kind of hand in hand with our discussion that transpired in class the first day that we had class last week. And that would be to recognize that anytime a limit approaches infinity or negative infinity, that's when you compare the numerator denominator's degree. So if we see that the numerator has a degree of 1 here, we technically look at that denominator as a degree of 1 as well, right? Because the square root of y squared is going to have a y to the first in it. We then could say we could divide the coefficients. Now the coefficients would be a -1 over a square root of 6, right? Now, the problem with this is that this particular problem shows that y was approaching negative infinity. Now, does that automatically mean that you just change this sign? And the answer to that's no, although that might be the case most of the time. What it means here is that you have to kind of look at how we would have gone about using our long cut, that procedure that said the square root of y squared is really equal to not just y in this case, but it's really equal to -y, because y is already going to be negative. So when we would have divided the top by whichever one of these two that was more conducive, it would have been the -y, which means this negative here would have been canceled, and thus a positive would have come about. And so that is going to be our answer. So you want to be careful with that. And if that doesn't make a lot of sense, please feel free to chime in and I can help with that a little bit. Now, I'd like to give you an alternate problem here. What if it question wasn't find the limit, but it was what are HAs? This is a little bit of an issue that I saw on the quiz that you guys took on Friday. What are the HAs? In this case, you have to find both limits, the limit as y approaches positive infinity and the limit as y approaches negative infinity. And you've got to be very on top of things to know that it's going to produce both answers. I think I tripped up quite a few people on that problem where you only thought a horizontal asymptote was going to occur at one of the two answers. And of course, you want to express these as horizontal lines. Okay. Now, if you don't like what I just did here, and you're like, man, I really need to see like the computations, remember what we did. Look in your notes. We would have divided the top by negative y, and the bottom by square root y squared for this limit. And if we were doing the limit as y approaches positive infinity, then we divide the tops by positive y's and the bottom by square root y squared. All right. Hope that makes sense. You guys are kind of quiet in the chat. That's all right. You know, maybe there isn't much to talk about. I would like to talk just very briefly about 19, because what I have noticed is that students tend to make up their own rules in calculus. Don't do that. Okay. What I mean by that is that you see a limit and you're like, oh yeah, record showed me that really cool thing that says you compare the degree of the top with the degree of the bottom, and whatever those turn out to be is going to be my sort of go-to to figure out what my limit is. Oh, so the top is 1, the bottom is 1, so the coefficients are both 1, and so the answer to this limit's 1, and that is wrong. You don't use the rule of looking at the degrees of the x's unless x approaches infinity or negative infinity. Otherwise, you are throwing away the first 2.5 weeks that we had of class when we talked about limits when x approached numbers other than infinity and negative infinity. So be very careful about that. When x doesn't approach infinity, guys, you green light. Well, you cross your fingers and hope you can green light. Just try to avoid 0 over 0 or constant over 0. You try to like look at that a little bit more carefully. So in this case, I think we get constant over what would be 0. Am I right? It's definitely a constant over that 0 value. Now, if you see that this is just simply going to be, well, something really close to -2 on the right side. So what would that be, like -1.999, right? Remember, we're on the right side of -2. Okay. Now in the bottom, you do the same thing, 1.9999 plus 2. Hopefully you see that what you have is just something approximately -2 on top and approximately, what is this, guys? Positive 0.001 on bottom. So you think, okay, I have a negative number over a positive small. That's going to take you to negative infinity for your answer on that. And a lot of kids can do this. A lot of you are developing this skill. I'm seeing a little bit less and less of that written on your papers lately because you're able to kind of reason through it. Oh, something close to -2 over pretty much 0 is that negative infinity. Now, of course, if you want to really polish this up, you could say therefore it doesn't exist. But honestly, the negative infinity is the most important part there for sure. So, all right, we do have a request to look at a few problems here, kind of in this area. So I'm going to hit up number 18, if you guys don't mind, the limit of x over tangent of x as x approaches 0. Now, if you try to green light, I think you can see there's trouble right away. X is going to be a 0. The tangent of 0, you're starting to probably, those of you in trig right now, pick up on the fact that the tangent of 0 is going to be 0. The reason is because the sine of x is the numerator in tangent, right? Sine over cosine, and the sine of 0 is going to be 0. So what this means is that you have to do a little bit of trig manipulation. This is going to utilize one of those two special trig formulas. And I'm going to write those down here in the space where 21 is. I would go into tomorrow's test and just have these looked at, right? Just make sure that you're kind of comfy with these two guys. Okay. Now, keep in mind that there's alternate versions of these. There's one where the sine and the x are switched and the limit is still 1. And then there's one where the cosine and 1 are switched. And oh, I didn't even write the answer. The answer is 0 for that. I'm not going to say, if this appears on your test, it would be one time, 1 point maximum. And I promise no more than that. But these aren't going to go away. They're going to be important down the road. And so I really want you to kind of be tuned into them. So what you're going to do with this is do some algebra. Tangent of x can be written as sine over cosine. I guess that's not really algebra, right? It's more like trig. But next you're going to do some algebra, right? Or arithmetic, basically. What happens whenever you divide fractions? Well, hopefully by now you realize that that is just the multiplication of the reciprocal. So x would be multiplied by cosine over sine. One of the things that you guys have struggled a little bit this year, I think you're going to get better. Every year there's a different little kind of deficiency that I notice that 20 plus students are struggling with. This happens to be one. It's not everybody. And then at this point you can kind of put the puzzle pieces together, put the x over the sine of x like that, and then multiply by cosine, right? You could even split this into two limits right now. As long as each of these limits has an answer, they can't have a D and E. Otherwise, you got to do some really goofy things like one-sided. And I think that these are okay, guys, right? Because the first limit, I'm going to highlight that in this beautiful green color. How's that? That is going to be the adaptation of this first limit, right? That first limit is 1. So the thing that I just highlighted in green is just equivalent to 1. And if you ask me how, I'm going to say, do you want to see the squeeze theorem proof again? Because that's where it came from. This was that first time that we saw mama bear, baby bear, papa bear, if you remember, right? So it's been proven. You just now have to like lock onto it and remember it. And then over here, this limit of cosine of x, that is a green light. And hopefully by now your trig will let you know that cosine of 0 is 1. So this problem is what? 1 times 1, which is equal to 1. If this is a multiple choice, you can choose to show as little work as you want. If it's a free response, well, it's not going to be a free response. So let's just leave it at that. Because I'm not going to be judge and jury about how much work you should show and not show, because I know that some of you can do a lot of this in your heads, and that's totally fine. Flashcards. Sometimes it's really difficult to convince students the benefit of this until it's too late. I'm going to tell you that you're going to see a ton of formulas in Unit 2. Derivative formulas. Derivative of 1 over x, derivative of e to the x, derivative of natural log of x, derivative of tangent, cosine. And it's really frustrating because if you don't know those basics, trying to do greater things with them are going to be very complicated. And so the quicker that you can start thinking about putting some flashcards, whether they're electronic or handheld, physical index card copies, it will pay off in the long run. And let's be honest, you probably have seen a few things in this unit that are flashcard worthy. Maybe a few of these special limits like this. Put this on the front of a card, put this on the back of a card. How cool is that? Do this on the front, do this on the back. Maybe you might want to throw in, what's our good friend as x approaches infinity of constant over x? You guys remember what this is, right? If the bottom gets really big, why don't you guys show me that answer in the chat, just to make sure that you're paying attention, right? Throw me a private DM. What is this limit? The limit of c over x as x approaches infinity. This is going to be your front of the card. This would be the back of the card. And, well, I got 2 answers. 2 out of what, 11 of you, I think? 3. Okay, they're coming in. I think you guys know it. You were just probably like, do I have to like really touch my keyboard? All right. 0 is the correct answer, you guys. So, little things like that, it could really go a long way. I got a crush to look at number 20. By the way, number 20 is going to utilize the limit that we just talked about. and it's going to use it quickly. So in this particular case, you are allowed to split the limit into two separate pieces. Remember, we had a discussion of, of that particular limit property, as long as both of these limits are defined, right? If either one of these is a does not exist, we're in trouble. And very quickly we discover, we're in trouble, right? Well, I don't think we're in trouble because the limit of 1 is 1. Nothing is going to change that. But over here, this is the limit of 1 over something that's going to be really small. That means that this has really big ideas. He knows he's going to be big, but he could be positive and big, or he could be negative and big. And I know that that is so confusing. Negative and big, shouldn't I say negative but super small? And so I get that. I don't like to use the word big sometimes if I know we're going to be negative. And that is exactly what's going to happen here. This is going to be a very small number close to 0, but negative. And what that means is that we're going to be taking negative infinity as our value. 1 over something close to 0 that's negative is negative infinity. And of course, if you add 1 and negative infinity, that's just negative infinity. I know you could say therefore does not exist, and et cetera, et cetera. Now notice that's not quite that limit property, right? I said it's kind of similar to it. So I suppose we could throw in another little property, something like the limit as x approaches 0 of what? Constant over x again. And we could say that this is equal to, well, in this case, this one's tricky. I don't like this one because it's actually does not exist, because it could be negative infinity, it could be positive. So maybe if I write it up like that, and I could write this one up, the positive version like this. And again, right there, instant 5 flashcards that wouldn't take much time on your part to put together. You have them for the rest of the year. You're all good to go. From one year to the next, I have debated on using an assignment where I physically do require you to make flashcards. It is one of the easiest grades that you'll ever get because, I mean, really, it's just a little bit of time. I haven't done that last couple of years. You can probably guess why, just because with all the craziness and interruption. But I may gravitate back towards that, and if I do, it would occur in Unit 2. So just to kind of keep a heads up. 29. Now that's not on this page, but I don't mind switching over here and taking a look here because it's not a limit problem, but it's going to segue right into the next group of problems I want to talk about. So find the x values at which f is discontinuous, and then let me know if they're removable or not. So the idea here with any kind of a fraction problem, if you're finding discontinuities, if you're finding asymptotes, what other things did we do with the, if you're finding limits, what's the name of this unit again, Mr. Record? If you're doing anything to a rational function, okay, I know I just said a really long word, rational function. It means fraction, right? Rational function means those ugly fractions you see in algebra, okay? That means you're going to want to factor it first. You've got to kind of get this down to where you can maybe reduce it, not have to kind of deal with the large numbers, et cetera. So there's our first factoring step. Yeah, you have to, be comfortable with greatest common factor factoring. That is an Algebra 1 power standard. That's a class that you took several years ago, so we should be good there. The 2's will cancel. We could do some more factoring to see that the x squared minus 9 will become x plus 3, x minus 3. And so, yep, these x plus 3's will cancel. This might start to look a little bit like the first quiz that you took this past week. We got to know that x equal, now careful, watch this, the sign that canceled, x plus 3, that is the factor. The root is x equal negative 3, right? You have to change the sign, you guys. There's a difference between a factor and a root, something that was very prominently discussed in the early stages of your algebra. x equal 3, that is coming from this one. So I'm just going to kind of point so we know where they're coming from. This is going to have to circle around. Okay. So what do we have at each of these? Well, the one that canceled is the removable. It's the removable discontinuity. The one that doesn't cancel is the non. But notice how the sign kind of changed, because we had quite a few people that struggled with that on that quiz early in the week, and it was kind of sad because a few of you kind of came to me, and some of you knew what was right. It's just that you circled the wrong problem, the wrong answer choice, and obviously if you do that on the SAT, if you do that on the AP exam, there's no going back, right? So make sure that you are answering the question that should be answered. Okay. Now, if you wanted to know more, the removable discontinuity, you don't have to state this, but that's going to be a whole, and the non-removable is going to be a VA. And that kind of segues nicely into problem 30 that might help you remember all of that business. So, okay. Very good trio of questions. I thank you for those. I do have another one here that I wanted to talk about. It's one of the last ones that I wanted to talk about. Number 33, actually 32 and 33. These are three great little problems. They're kind of like true false types here. In 33, it gives 5 different statements and it asks which of the following statements is false. That is meant to indicate that only one of those answers would be true, or, well, false. One of those answers would be written so that it's viable. It's saying something that's not going to be happening, right? Which of the following statements is false? X equal A, is that in the domain of F? Well, the domain is all of the X values that you're allowed to have. It looks like we're allowed to have a bunch of X values on this graph, but when you get at A, whoa, we get this open circle. Hopefully you can see that on your handout, but then above it, you have that point defined, which means that A is in the domain. So this guy is going to be true, not our correct answer. Now, we might be able to hit a few of these quickly. Does the limit as x approach a from the right and the limit as x approach a from the left of function f of x equal each other? And they do, right? When your fingers come to a open circle, that means that the limit does exist. So by default, that means C is true. That's the whole definition of how a limit exists. Now, what about the limit of f at x equal a, x approaching a, being equal to f of a? Doesn't look like that's happening, right? In fact, this is the third final criteria of whether a function's not continuous. And we can see that this function's not continuous. It's close. It's the closest thing to continuous that you can possibly have. So that's definitely false. And you can see that, well, that's true because it says not equal. I'm sorry, you guys. It says not equal to each other. Obviously, E is the false one, because this function is certainly discontinuous at x equal a. So, had a great question about jumps. Do jumps only occur in piecewise functions? And I will say, from everything that we have studied, yes. It's just notorious. You got a couple of pieces, you approach the top piece from one side, the bottom piece from the opposite side, they give you 2 different answers. That's your jump. And I don't really want you guys to make it any more difficult than that. I think that's a really good observation on your part, and it should work with you. That should work for you throughout the rest of the year, at least the times that we talk about jumps. I love number 32 now, true or false. If the function as x approaches c has a limit that's equal to L, that means that f of c has to equal L, right? False. Look at what we just discovered in 33. They're obviously not the same. And you can probably tell that's probably an important idea. That's why I'm really emphasizing that quite a bit on this review guide, so that that sits with you pretty good. Sits with you pretty good. Okay. I kind of lied. There was one thing I wanted to discuss here in 34, if you wouldn't mind. Um, a lot of students are a little freaking out about this delta X. And I was with actually with your counterparts that are in Mr. Meunier's class. I just happened to be in the room, and a few of them were working on this problem, and Mr. Meunier wasn't in the room, and they were like, they kind of rushed to me like, what is this delta X? And I'm like, oh yeah, that's kind of different. You guys, you're probably, I bet you're used to seeing this as an H, because that's what I used more often in some of the earlier materials. That's really all it is, you guys. I like delta X because it kind of defines what H is. Delta means, I'd ask you this if I wanted to take the time and have you guys quick or poll or whatever, but it means change in. Delta X is change in X. I think a lot of you knew that anyway. It's very universal. Um, it's just attached to the X as it is like one variable in and of itself. So when you FOIL out X plus delta X squared, it's not much different than FOILing out X plus H squared. And I might do that on a separate little page here so I don't run out of room. So here's what it's going to look like, you guys. X plus delta X times itself. Let's really break it down. Break it down. All right, so X times X, that's your first, right? Yeah, you know that, X squared. No surprise, right? Outside, X times delta X. Don't overthink it. What is X times delta X? I just told you, it's X times delta X. But to make your life a little easier, wrap that delta X in parentheses, and I think it's going to be a little bit more straightforward. You can just kind of join them with the parenthesis, and that means that they're being multiplied. Hey, we have the same thing inside here. Nope, it would not matter if you put the delta X first, right? Nope, it doesn't matter if you put the X in parentheses as well. Nope, it doesn't matter if you put a dot in there. I'm okay with that. And then if delta X is multiplied by delta X, let's kind of use that same philosophy to keep the delta X in parentheses and square it. And then what will end up happening is X squared plus, combine your like terms in the middle, you get 2X delta X, right? Like I said, don't overthink how you combine these. It's like I'm telling you, hey guys, I have this really cool thing in my hand. You want to see what this really cool thing is? I want to show you. It's this remote control. Isn't this really cool? Okay. It's called an X delta X. I actually have two of them, right? There's another one over here. I'm going to put them together. How many do I have? 2X delta X. That's how you would think about adding like terms like that. And I don't want to blow your mind here with this, but you see the 1, 2, 2, 1. Hey, Pascal's triangle. That's a cool thing, right? Pascal's triangle always will tell you what the coefficients are of your binomial expansion. Heaven forbid if we had X plus delta X to the third power. I promise you that won't happen on my test. You're probably going to use 1, 3, 3, and 1 as the coefficients of those individual pieces. But I don't want to go into that because that's kind of getting ahead of ourselves. So I'm going to take this result just really quickly and throw it back into this expansion. And let's see where we're at. We have the limit as delta X approaches 0. And then we had, remember, X squared plus 2X times delta X all together. There's that middle term. That's the OI part of FOIL. OI. OI. Don't they English say OI a lot? Right? I watched Ted Lasso. I always see those characters saying OI. When I was in England, I heard a few people say OI. All right. 2 times delta X. Again, I'm going to keep the delta X in parentheses there. That's a delta, not a 4. And then plus 1, and oh, what is this? Continued on like next line. No, I don't want to do that. Let's distribute the X squared and just kind of squeeze this in as much as we can. Oh, okay, I made it. All over delta X. And then at this point, I refer to this as what? Cancel palooza. You see a lot of things that start going away. X squareds go away. The 2X's go away. Oh, the 1's go away. Didn't almost see those. Everything up in the numerator, you should notice, have a delta X in them. So to save you a little bit of time, you could cancel a delta x out of each of those numerator terms, right? It's kind of like factoring out a delta x so that it'll cancel with that delta x in the bottom. And so you're left with 2x plus, now this delta x that was squared is still going to have a delta x to the first. I'll put it there for emphasis. And that the tail end of this is a -2. And now you can green light. And that delta x just becomes a 0. It will go away. And this is your final answer. Some of you that are in physics are now, I think, starting to get a little bit more into your derivative lesson. Maybe you guys look and say, whoa, that's the derivative of that thing. Yep. And don't want to like rock your boat, but the very beginning of the next lesson, which we're not going to start after the quiz on or the exam on Monday, but we'll wait and start that either Tuesday or Wednesday, is all about the definition of derivative. So we're going to be doing this one more time, you guys, these kind of limits that are a little bit crazy with these crazy things in it. And then we'll gravitate to something a little bit simpler, I hope. So hopefully that helps out. Okay, I'm going to go ahead. We got about 21 minutes here. If you need the time, I'm going to stay on and I'll let you guys ask any questions about anything that's on here. I know that we have another couple of pages here that we didn't address. This is like a part 2 where I started the numbering process over again. I wouldn't read anything into it. I think these are probably more calculator assisted questions for sure. Obviously your complex limits are there, which I kind of thought somebody was probably going to ask about those. So we'll see how that goes. And then I know you look at this problem and the first thing that you want to do is just start like shaking, right? And trembling. You're not allowed to ask me to help you with number 6 until you try it, okay? It's not as hard as you think. It has lots of letters, an A, B, C, and a D that you have to find. Typically, you're kind of only used to having to find maybe an A and a B, but a couple of these kind of take care of themselves a little bit quicker. But I'm not saying that I won't work the problem tonight, but if anybody's going to ask it, you have to definitely promise me that you've tried it, and hopefully everyone else in the room here has probably tried it. Maybe you could even start looking at it right now if the questions that other students are asking here are not things that you need to worry about. So already got some great questions coming in on part 2, looking at number 5. And so I'm going to be really honest. If you guys had not asked anything, instead of just closing off the stream, I would have probably looked at any number of these 3, 4, and 5, because this is back to that odd limit out, right? The trickier limits that we come across. Your unit exam isn't full of these. It might have 1, 2 at the most. I want you to be good at them. I will tell you, I think you're about the best group I've ever had at them, but that doesn't say that you're fantastic as a group, because this is hard. This is one of the hardest things that we've done, but I really like the fact that you weren't scared of them. At least most of you weren't, right? So number 5, what is the limit as x approaches 1 from the right of f of x plus 1 over g of x plus 3? Well, the first thing that we want to do with this is probably split this apart maybe into 2 separate limits, right? Just make this a long division statement. But more importantly than that, I do not want to shift either of these functions left or right, right? We talked about that in class. F of x plus 1, that means that, f would shift left 1 unit, correct? F would shift left 1 unit. G of x plus 3 means G would shift left 3 units, okay? And remember, the shift is opposite of what you would think, right? When you have a plus sign, kind of think that's positive to the right, that's going to be a left shift. Now, remember what we said. We said, no, let's not shift the function. Let's leave this function as f. Let's leave this function as g. Let's shift the target x is approaching. And so if x approaches 1, instead, we're going to let it approach 2, right? We're going to physically add. Our shortcut said take whatever operation that is and apply it to that number. 1 plus 1 is 2. Yep, it's 2. Likewise, downstairs, the limit as x approaches not 1, but 4. And we still stay from the correct side. Okay. Now, what I like about this is, remember we said that, oh crap, you're not really allowed to like split limits apart like this in case they doesn't exist, right? Well, if that were the case, then we have to do a one-sided limit approach with them. We have to do from the left, we have to do from the right, but this is already the case. It's already a right-sided limit, so that's going to make things kind of easy. So if we go, x approaches 2 from the right. Where is 2? 2, where are you? Right, here you are. Okay. Approach 2 from the right. Looks like we're going to get 3. There's your numerator, guys. X approaches 4 from the right. This is the g function. 4, where are you? 1, 2, 3, 4. Here you are. Approach 4 from the right. -2. And so there's your answer. I mean, -3/2 would be fine. 3 over -2 is also fine. But hopefully that makes sense to you guys. I'm being real careful. I'm not mentioning anybody's names in this video because this one's going to be posted for the public to see in case other schools and students want to use some of this to help them review for the exam. But thank you much for that question. It's a good one. And hopefully that makes sense. Got a request for going back here. Whoops. Problem 36, which is obviously on the first part here. So we'll take that. And I got a few other questions here that are coming in as well. So you guys are doing great with those. I appreciate that. Create a function such that the limit as x approaches 5 does not exist because it is approaching positive infinity from both the left and the right. The challenge is to show both the function and the graph. I think that this is a great question. I'm not so sure that this is a great exam question. Sometimes I like to throw some problems on the review guide that kind of get you guys thinking a little bit. This is very open-ended. I hope that just with those words, you guys aren't, oh, did he just say that this is on the test? And then you guys go run and get a sandwich right now, right? Hopefully you'll still kind of tune into this because I think there's some really good things in this problem. So maybe we think about the graph first. I don't know. I mean, we could think about, okay, as x approaches 5, so that means we need to have something kind of going on here at 5, right? Apparently I can't count. That's only 4. Let's try this again. 5 would be right there. So as x approaches 5, we see that we get positive infinity from both sides. So does that kind of indicate that the graph might look something like this? You all good with that? And the connection I want you to make here is that that is a vertical asymptote, okay? And I have a feeling that the majority of you know that. You probably latched on to that. The problem with this is, do you feel like you know what that equation is? And that's where that might not be reinforced, because this is really, I'm gonna be honest, this is more of an algebra question. It's probably not within my right to put this on a calculus test. But I wanted you to just look at this graph. Remember what my name was for this. If we were all together, I would probably ask, I call this the volcano graph, right? By the way, I used to think that that was something that I made up, but I kind of run across other teachers across the country, and it's kind of pleasant to see that they think the same way that we think sometimes. And I've heard a few other teachers say, yeah, that's what I call it too. All right, it's like Mount Fuji. All right, so we have this volcano graph. Do you remember what the granddaddy volcano graph function looks like? The parent graph. It was in the summer packet, and it looks something like this, 1 over x squared. That was him. All you have to do to this is shift it over to the right 5 units. Do you remember what that does to the curve? And I don't know. For the two of you, the girls that answered this, that asked the last 2 questions, I couldn't have planned it out any better because back to back, they fit so well together. So thanks for that. It's almost like we planned that. But this is going to be 1 over, and then shift to the right means you have a minus now, right? A minus 5 in the quantity squared. And so that would be the function that I'm looking for, you guys. A good problem, has some good calc in it, not probably something that you have to worry yourself out going into the test. Was asked, will there be an oscillation problem on the test? I want to make sure before I totally answer. I don't have a graph that's oscillating that requires you to kind of like squint your eyes and like, okay, what is he meaning with this? Because sometimes those can be tricky. Would it be good to know what's one of the ways that a limit would fail to exist, right? And it's because a graph would oscillate between 2 fixed values. I think that's good to know, but you're not going to have a specific graph that's oscillating that you have to decipher information on, okay? Remember, there's 3 ways a limit doesn't exist. This is way back to the beginning part of the year. Oscillate between 2 fixed values, approach 2 different numbers from the left and the right. There's your jump, piecewise function typically. And the other one is graph increases or decreases without bound. If you don't like to say those words, you can say the function approaches either negative infinity or positive infinity as x approaches some c. So, all right, those are going to get the jobs done. All right, we've covered pretty much the stuff that I really wanted to hit up. If you have a lot of anxiety about problem number 6 here on part 2, I did make it a point to make my answer key extremely thorough. I skipped nothing in that. In fact, I have it called up here. I don't even mind sliding that in here just for a second. But this thing here is, like I said, this is massive. You could answer this much faster because you probably don't have to show each of these little steps, but I showed them in case you ended up getting lost. I even sketched the graph, which isn't part of the problem at all. But once I found the values of A, B, C, and D, I basically wanted to make sure that I wrote a problem that made sense. All right, I wanted this function to be continuous. Otherwise, it's a silly question to even be discussing. So look through that, and yeah, you should be okay. You guys already proved yourself when you did a very good job on the problem from the 3rd quiz, the first quiz from last week, where you found the values of A and B. Your notation was good. I know a few of you, may have scored very little on it. A few of you just like missed a nitpicky point because of a little error. But I thought you did a fairly good job with this. So, okay. Other advice that I could give you on a free response question. If a problem has anything to do with a limit and it looks like it's going to take a step or 2 to solve, write your limit statements. Make sure you're not lazy and just do all of the work without the limit. And then somehow you green light at the end. And I'm going to say, where did that value come from that you green lighted all of a sudden? I would prefer that you have the limit with every step of work, but I will only require the limit at least down at the very last line before you green light. That's the one that I'm truly looking for, okay? I have a stamp that I stamp on the paper. It says, write your limit statement, that somebody actually bought me a long time ago because they saw me grading papers at a conference, and it was my birthday, actually, that same week. And they were feeling sorry for me because I was writing that statement all the time. And so they bought a stamp for me. had it delivered to my house. All right. You guys, I know we're a little early, about 8 minutes, but I don't have anything else that I wanted to cover. Don't forget, use AP Classroom if you'd like. I know there's a lot of great things there. Um, that's my go-to place for you after you've looked at the review guide for sure. And again, I apologize that you just have a short period of time with that. That will not be the case in the future because those will be opened 1 week to the day of our unit exams from going forward. Um, I think there's a lot of things in those progress checks that go above and beyond what I want to test. If you follow them and understand them, you will crush just about anything that I would put on this test. Because some of them are pretty tricky, but there's a few that you'll know when you see them that are like, man, he's really talked about these kinds of problems a lot. Seems like I've seen this kind of question over and over again. That's probably a good sign that that could be a type of multiple choice question that I'd like to put on the test. You guys know my philosophy. My philosophy about getting a 4 or 5 on the AP exam is all in the multiple choice, setting the stage to have strong multiple choice, to have a 2 already or a super high 1 when you're done with the multiple choice, so that the rungs of the ladders to do it to a 3 to a 4 are much shorter and you can crush those a free response question at a time. So all right. Looks like we don't have many more questions coming in. So if it's all right with you, I'm going to close off the stream. I'm going to actually stop the recording first. Thanks to you guys that were joining us. Tape delayed, I guess. I'll get this. I tried to get this process really quickly so that you guys can start watching it. But I want to wish you guys also good luck on the test.